My dear students, in this class we are going to learn about or discuss about very interesting and very curiosity and very application level topic is arithmetic progression. Before going to arithmetic progression, we are now to about basic concepts of arithmetic progressions. First we know about, we are all already known about what is arithmetic. Arithmetic is nothing but study of numbers or study of number system. We call it as an arithmetic. Here we know about the word progressions. What is progressions? Progressions we also called as sequence. Sequence is nothing but, before going to know about sequence, we are all learned about in previous classes patterns. What is patterns? Patterns is a list of number arranged in a particular rule. What about particular rule? What do you mean by particular rule? If any rule is there, if we consider natural numbers, the natural numbers are 1, 2, 3, 4, 5, 6, up to so on. Here one rule is there. It is the first term. You consider as a first term. This is a second term and third term, fourth term, so on. Here regarding this one, first term we can add 1, we get second term. Then second term we add 1, we get third. Then 4, like so on. This is the one of the particular rule. One constant number is add all the term, we get next term. And another one, 1, 2, 3, 5, so on. This is also a pattern. Here we can add 1 plus 0, then we get second term 1. Then we add 1 plus 1, we get 2. 2 plus 1 we get 3. 3 plus 2 is we get 5. This is also one type of pattern. Another one pattern, 1, 1, 1, 1, 1, so on. This is also a pattern. We add 1 plus 0 is also a 1, 1 plus 0 also a 1, 1 plus 0 also a 1, 1 plus 0 also a 1. Where constant number 0 you can be add, then all the terms will be obtained. Another one of the pattern, 2, 4, 1, 8, 16, so on. Here the product is there. 2 2s are 4, 4 2s are 8, 8 2s are 16, so on. This is also a pattern. Then pattern is a list of number we can arrange in a particular rule, we called as an patterns. These are all patterns, list of in special order, then we called as a sequence. This sequence is also called as a progressions. The sequence is also called as a progressions. Next we move on, arithmetic progression. What did it mean by arithmetic progressions? Here 1, 2, 3, 4 examples are there. In regarding these 4 examples, first example is an arithmetic progressions. Then what is arithmetic progression? Arithmetic progression is a arithmetic AP. It's nothing but simply called as an AP. Arithmetic progression is a list of numbers list of numbers, list of numbers in which list of number in which each terms in which each terms are obtained by an addition of fixed term, by an addition of fixed term. Here we can add 1 to first term, we also add 1 to second term, also add 1 to third term. Fixed addition of fixed term to the preceding term. Preceding means previous term. To the preceding term. Except what? Except first term. We call as an arithmetic progression. Arithmetic progression is a list of numbers in which each terms are obtained by a addition of fixed term to the preceding terms, or addition of fixed term or number. Fixed term or number to the preceding is nothing but previous term except first term. We got a arithmetic progression. Here every number we call as a term. Every number is called as a term. Also represented as here by using alphabetic letters, also represented as A1, A2, A3, A4, A5, A6 up to so on. These are all represented as terms. A1 is a first term, A2 is a second term, A3 is a third term, A4 is a fourth term, and so on. Nth term, An is a nth term. Here n is always positive. N is always positive. Why n is always positive? Because every term is there. That's why n is always positive. Then let me move on. Types of arithmetic is nothing but types. Arithmetic progression. Which are types? There is a classification. Is nothing but classification. One is finite, another one is infinite. Finite, another one is infinite. Finite arithmetic progression and infinite arithmetic progression. What is finite arithmetic progression? In this finite arithmetic progression, that term is countable, or that term will be n. For example, 1, 2, 3, so on, 10. There are 10 terms are there. Here, these progression we call as an finite number of arithmetic progressions. Is nothing but finite arithmetic progression. If the arithmetic progression is uncountable, it never ends. For example, this one 1, 2, 3, 4, 5, so on. There is no end. That we call as an infinite arithmetic progression, or arithmetic progression of infinite. Let me move on. In these terms are represented as in alphabetic letters A1, A2, A3, A4, so on up to n term is An, and also is there. The term is also there because of this here. If n is 10, then it is a finite. N is countless, then it is a infinite number of arithmetic progressions. Next we move on. Common difference. Common difference. Common difference. Here common difference we can be represented as denoted by the symbol small d. Common difference is also denoted by a symbol small d. How can you obtain the common difference? The common difference is a fixed number can be obtained by, common difference is a fixed number can be obtained by next number minus previous number. Is nothing but is obtained by previous number subtracted from next number. Is nothing but d is equal to next term or number, next term minus previous term. Next term minus previous term. Here d is equal to a2 minus a1 is also a common difference, and also d is equal to a3 minus a2, d is equal to a4 minus a3, and so on. These are all common difference is also a constant in arithmetic progression or fixed value. It is a fixed value. For example, one is natural numbers 1, 2, 3, 4, so on. Here 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1, 5 minus 4, 1. These are all what type of example? Arithmetic progression. The common difference between two terms is 1, 1, 1, 1 and so on. Therefore, d is equal to a2 minus a1. If it is considered nth term, if it is considered nth term, d can be written as d is equal to an. D is equal to an minus an minus 1. Because of an is a last term, that's why if we subtract one term, previous term will be obtained. That's why we can be written as n minus 1. D is equal to an is equal to an minus an minus 1. We can be calculated the difference between the two terms of an arithmetic progression. D we can call it as a common difference. D can be called as a common difference. Are you understand? Next we move on. If we write any arithmetic progression, the value comes from, if we given a or d. For example, first term is 2. We can write these two to any arithmetic progression. We can't write any arithmetic progression because there is no about common difference between any two terms. If we given the common difference is 3 of any arithmetic progression, of any arithmetic progression, then you can write any arithmetic progression? No, because only common difference is there. There is no any first term or any other term is not given. That's why if you required fact is, the required fact of arithmetic progression is the first term is always be given and also d is always be given. Then we can be calculated a arithmetic progression or find out a arithmetic progression. For example, a is equal to 5, then d is equal to 2, then we can be written as 5, next term is 5 plus 2, 7, next term is 7 plus 2, 9, next term is 9 plus 2, 11, so on. This is one type of arithmetic progression, or this is the example of arithmetic progression. Then general form of arithmetic progression can be written as, how it can be written general form of arithmetic progression? You all know about in the alphabetic letters, the term will be written as A1, A2, A3, A4 up to so on, nth term AN. By using this, the general term will be written by, we all know about, is simply called called as A1 is equal to A. Simply called as A1 is equal to first term. We consider as A1 is equal to first term A. Next, A2 is equal to, we can add previous term. A plus what we can be added? Difference will be added. Nothing but A2 is equal to A plus D. Next, A3 is equal to A2 previous term plus difference D is equal to previous term A plus D plus this one is a D. A plus 2D. A plus 2D. This can be also written as A plus 2 minus 1 into D. We can subtract 2 minus 1, 1. Here also can be written as A plus 3 minus 1 into D. And so on. And so on. Nth term. Nth term, how can be written? In the nth term, the previous term will be an minus 1 because subtracted from 1. Then we will get previous term. An is equal to an minus 1 plus D. An minus 1 will be, what will we obtain? A plus n minus 1 into D. A plus n minus 1 into D. The previous term n minus 1. Here also 2. Here also 2. Here also n minus 1. Here also n minus 1. And then an is equal to A plus n minus 1 into D. A plus n minus 1 into D. This is the finding arithmetic progression of nth term of an arithmetic progression. The nth term of an arithmetic progression. The formula becomes an is equal to A plus n minus 1 into D. A plus n minus 1 into D. For example, first term will be A. Sum of the arithmetic progression is 2, 6, 10, 14, 18 and so on. Now we can be find out next term of, how many terms are there? 1, 2, 3, 4, 5. Sixth term is is nothing but 22. Next term is 26. So if we can find out that 100th term. Now we are all calculated about all the terms. Here also 1, 2, 3, 4, 5, 6th term, 7th term, 8th term, 10th term, 20th term, 30th term, 40th, 50th, 60th, 70th, 80th, 90th, 100th term. But by using this formula, we can directly find out what is the 100th term value of this arithmetic progression. Here, first we calculate first term of an arithmetic progression. First term A is equal to 2. First term is A is equal to 2. Next, D is equal to second term minus previous term or nothing but next term minus previous term. 6 minus 2 is equal to 4. Here also 10 minus 6 is equal to 4. 14 minus 10 is equal to 4. 18 minus 14 is equal to 4. Like so on. Here D is equal to 4, A is equal to 2. Then we substitute this formula. A 100. Here one of the term is there, n. What is n? N is nothing but 100th term. Is nothing but n is equal to 100. N is equal to 100. A 100 is nothing but 100 term. 2 plus n minus 1. 100 minus 1 into D. D is nothing but 4. D is nothing but 4. 2 plus 100 minus 1 is equal to 99 into 4. 2 plus 4 nines are 36, 6, 3 carry, 4 nines are 36, 36 plus 3, 39. 396 plus 2, 398. This is nothing but 100 is equal to 398. The 100 term will be 398. Then common difference D is also a positive is also a positive or negative, positive or negative, or it may be zero, D will be positive, either negative or it may be zero. For some examples is there. Here common difference is 4. Here also common difference is 4. That's why we call it as an arithmetic progression. The common difference will be this arithmetic progression is positive. The common difference of this arithmetic progression is positive. Next, another example is there. 250, next 200, next 150. Next 100, next 50, so on. Here common difference. What is the common difference? 250 minus 200 is wrong. The second term or next term minus previous term. Next term is 200 minus previous term is 250. Then 200 minus 250 is nothing but minus 50. Here also 150 minus 200. Here also minus 50. Here also minus 50. And also 100 minus 150. Here also minus 50. That's why the common difference D will be positive, either negative. Next, last we move on. What is 0? Another example is there. For example, 3, 3, 3, 3, 3, 3, so on. This is also a pattern, or this is also a sequence, and this is also a arithmetic progression, one type of arithmetic progression. The common difference is here first term A1 are simply called as an A, next term A2, next term A3, next term A4, next term A5, A6, so on. Here D is equal to A2 minus A1 or nothing but 3 minus 3 is equal to 0. And also A3 minus A2, 3 minus 3 also is equal to 0. Here D is equal to minus 50. Here D is equal to 0. That's why we call it as D is always positive or negative, or it may be 0. Another one example is there. Example 2, minus 6, minus 3, 0, 3, 6, so on. Then we can find A 50th term. A 50th term. Here given, we can find out A 50th term. Given A is equal to where it can be started. It not can be started in 0. We can be started with first term A1 or A, nothing but minus 6. D is equal to minus 3 minus of minus 6 minus 3 plus 6. D is equal to 3. D is equal to 3. And also here also 3 minus 0, 3. D is also 3. Here also D is also 3. Here it will be negative, but difference will be positive. Can we observe that? Next, n is equal to 50. N is equal to 50. N is nothing but 50. Formula is An is equal to A plus n minus 1 into D. An is equal to A plus n minus 1 into D. Here substitute A 50 is equal to A value will become minus 6. Next, plus n becomes 50. 50 minus 1, D will be 3. Minus 6. Here plus first bracket will be open because of Bodmer's rule. 50 minus 1, 49 into 3. The bracket will be shown as into. Is nothing but product. Or it can be written as into sign. Minus 6 plus 3 nines are 27. 2 carry. 3 fours are 12. 12 plus 2 14. 147 minus 6 is nothing but 141. A50 becomes 141. The 50th term of this arithmetic progression is 141. Are you know? Next, another example. Example 3. 250, 200, 150, 100, 50, so on. Here, find out A 25th term. Find out A 25th term. It's nothing but 25th term. Given A is equal to 250, A is equal to 250. D is equal to 200 minus 250 is equal to minus 50. Then n is equal to 25. A25 or An is equal to A plus n minus 1 into D. A25th term is equal to A is nothing but 250. Plus n minus 1, n is 25 minus 1 into D, D is minus 50. Here observe that the difference will be minus 50. That's why we make it bracket. Bracket is nothing but into sign. 250 plus 25 minus 1, 24. Here also minus 50. If you remove the bracket, it can be subtract or add is there. That's why we put it in a bracket. A25. A25 is equal to 250 minus into plus minus 50. 24 zeros are 0. Next 24 5s are 24 5s are 120. 120 is nothing but 1200. Nothing but 1200. 1200 plus 250 minus 1200 is nothing but minus 950 because of the bigger value sign becomes minus. That's why minus 950. A25 becomes minus 950. Here all are positive value, but A25 becomes minus 950. Here observe that the value becomes decreases, not in increases. If we start with 50, then will we obtain positive. Here, this arithmetic progression, the value becomes decreases. What difference between there? Minus 50 difference is there, is nothing but common difference. That's why here 0 is come, next value become minus 50, minus 100, minus 150, minus 200 and so on. A25 term is minus 950. Next, another one most important example, fourth example, 4, 4, 4, 4, so on, so on. It can be find out a 200th term. Simply we say a 200 term is also a 4. Because the common difference between these two numbers are always 0. You can be check it out. An is equal to a plus n minus 1 into d. Here n is equal to 200, a is equal to 4, difference is equal to 0. Then a 200 is equal to, first term is 4 plus n minus 1, 200 minus 1 into 0. This value becomes 0. A 200 is equal to 4. Thank you.